Welcome back. So this will be our lab 5 for the e-tron and the introduction to electronics. We're using e-tron circuit lab books with the basics V3 intro to electronics. You can order these. I'll have the link in the description box below to where you can order it from. So what you're going to need for this lab is you're going to need your parts box. When you first purchase it, it'll come with looking like a parts bag. I've showed that in many of my videos. Here it is right here. Here's also what it looks like when you first get it, the parts bag. There is the website where you can order all the supplies I'll be talking about, etroncircuit.com. All right, let's get started with this. So in a moment, we'll move to our lab that we'll be working on. But let's go over, we're going to be on lab 5, page 18 and 19, and we're going to go over introduction to resistors. Now, you'll notice like in lab 2, I showed you how to calculate the value of a resistor. But in this particular lab, I'm going to show you or teach you some things about resistors. So let's first start off with what is a resistor. A resistor is an electrical component that is used to create resistance. And so that being said, it slows down current to protect other components in the circuit. So if I look at this picture of a built, my LED would burn out if it wasn't for my resistors. Okay, and if you try that, I promise you it will burn out. So don't do it so that you'll get to keep your LEDs. All right. We're going to go into an example of some resistors, and I'm going to use funnels. So today we're going to let water, here's the water, we're going to let the water represent the current, and we're going to take these resistors. So I want you to look at these funnels, which is I'm going to refer to as our resistor. Okay, so a real resistor looks like this, right here, a little bitty tiny thing. But we're going to let this represent the resistor, so you can just pretend like it has lead wires coming out of it if you need to do that. So we're going to have this one, and it's going to be our 10 ohm resistor. So this is a pretty good size hole. Okay. And then this one's going to represent our 10,000 ohm resistor. So it's going to give a lot more resistance. Remember, the bigger the number. Okay. So I'm going to get this set up, and I'm going to slide my lab over, and we're going to pour some water. So I want you to watch. Okay, so we're going to start with our first. Remember, this one's going to act as though it's our 10 ohm resistor. It's got the bigger opening. And I'm going to take this water, and remember, it comes to the lip, so it's going to be the same amount of water. And I'm going to pour it in, and I want you to pay attention to how long it takes. Not much difference than me just pouring it in. Okay, we finished. All right. So I'm going to put that resistor in that one. I'm going to take this water, dump it right back in there. And we're going to try it again. And let's see how long it takes us. Here's my next resistor. It's supposed to be like a 10,000, just representing like a 10,000 ohm resistor. So a lot smaller. Look at the difference. A lot smaller. Now let's see how much resistance this is it happening as fast as the other one? No, it's taking it. Okay. So that's an example of how resistance, the smaller and larger the resistor, the more resistance. So we use the water to demonstrate the electricity flowing. So when we had our larger funnel, water was able, or the current was able to move faster and work at a faster speed because there was not much resistance. But as I close up that hole and make it smaller, it takes more current. Less current can flow. More energy, I guess. Less current can flow through a smaller area. We still poured the same amount of water. We used the same amount of water. We still filled it up. It just took longer because we had more resistance. Okay, so that's what our funnels was representing as resistors. And then here's what our resistors look like in real life. Okay, so what you're going to need for this lab on page 18 in your book, if you have your book, Intro to Resistors, and this is lab 5, you're going to need an LED, you're going to need a battery snap, you're going to need 5 resistors. And I'm going to call these resistors out for you. So get into your parts box, and I'm going to call them out for you. So resistor number 1 is red, brown, gold. So you're going to be looking up in your parts box, and you're going to be pulling out red, brown, gold. If it takes you longer than I call out the resistor number 2, then just pause this video and grab red, brown, gold. Look until you find that, okay? I have found it. I've got it on my thing here, so pause the video if you have not found it. That's resistor number 1. Resistor number 2 is brown, black, red, gold. Resistor number 2, brown, black, red, gold. Resistor number 3. Remember, if you haven't found it, just pause the video. Resistor number 3, orange, red, gold. Orange, red, gold is resistor number 3. Resistor number 4, blue, gray, red, gold. Blue, gray, red, gold. And resistor number 5, brown, blue, orange, gold. Brown, blue, orange, gold. Resistor 5. Pause the video if you have not found all of those and laid them out into your lid. Remember, we have provided storage boxes. If you do not have these boxes, they sell them at Dollar General, Walmart. It's just a small storage box like this. And there's the lid to it, and we do all our work in there because these parts are small and it keeps them from rolling every which way. All right, at this time you can pause the video and calculate these resistors. So I have it right here on the little piece of paper. It says calculate each resistor. So write them down. This gives you good practice. If you turn back to page 13, I believe it is, there's a chart on there. Yes, page 13. I'll show you that chart real quick. Page 13 in your book shows you the chart. You'll just do the color codes and you'll be able to calculate these. Pause this screen at this time and you can calculate those. You can bring your work to class and I'll grade it for you. Okay, you can actually look over here on page 18 and see if your answers are correct. So you wouldn't even have to bring it to class, but if you want to, I'll grade it for you. However, in this particular thing, it gives you the answers to the resistors that we pulled out. All right, so there's a few more things we need to complete this lab. We need a circuit board, solderless circuit board that came with your kit. We need an LED, we need a battery snap, and we're going to need 3 of our wires. Everything can be found in your parts bag. I'll say those extra supplies again. We need an LED, a battery snap, your circuit board, your solderless circuit board, and 3 wires. Pause the video if you don't have all this, and when you do, you can unpause the video. All right, we'll begin with our lab. So you'll need your circuit board. And remember, we try to work everything inside so that we do not lose parts. Okay? All right. So we're going to take our first resistor. And our first resistor is red, brown, gold, which would be our 220 ohm resistor. And we're going to put it in I, J, and 10. I'm sorry, 1J and 10J, not IJ. 1J and 10J. So we're going to look at the 1, we're going to come over to J, and we're going to go 1J and 10J. So I'll grab a wire and I'll put it into, I'm sorry, my resistor, my first one, my 220 ohm resistor, and I'll put it into 1J. And we want to make sure we get good contact. So I told the guys the other day, hold it at the bottom and push, just like that. And then I just take my finger and pull it over so I can still have it. And then it said 10J, so I'm going to go right here. But I may have to move my phone because it's very hard to do this with one hand. It's nice to have your second hand. 10J. So there we go. Okay. Remember, we want to keep them neat, keep them organized, and nothing touching. Okay. So when I add my next resistor, I want to make sure it's not touching. Okay. Our next one was going to go brown, black, red, gold. Brown, black, red, gold. So our second resistor, and it's going to go in 1H and 11H. 1H. So I'm going to get it in there, 1H, and then I'm going to take and bend it over into 11H. And I may have to use my other hand so I don't get them. 11H. 11H. Okay, 1H and 11H. Okay, and make sure they do not touch, okay? Our next resistor will go into, our next resistor is orange, red, gold. Orange, red, gold. It's a 3.3K ohm resistor. And it's going to go into 1F and 12F. Are you noticing a pattern? 1F and 12F. So here we go. Got my resistor, 1F. And then I'm going to flip my finger. You can do it however you need to. 1F, and then I'm going to do 12F. This just helps me kind of keep my wires good. And then 12F. And this is so hard to do with one hand. Sorry, y'all. 12F. Alright. Are we noticing a pattern here? Are we seeing anything? Make sure they do not touch. So right now is my time to do a clean board. Making sure everything's on its own. I'll zoom in a little bit so you can see that. Okay, pause the video if you do not have that done, okay? Just remember that you can work at your own speed. Just pause the video. Okay. Alright, so that's our third resistor. Our fourth resistor is going to be brown, blue, orange, gold. Brown, blue, orange, gold. And I'm going to take this over here and make sure that it is... Alright, wait a minute. Okay, they got messed up. So brown, blue, orange, gold. So I wanted to make sure. So with that being said, let's put this one in, and it's going in at 1E and 10E. 1E, and then I'm going to curve it down and around and go to 10E. And I'm going to have to tilt my phone and look behind it because sometimes it's hard to look through my phone. 10E. And there we go. So I'll just push that down and make sure it contacts, because I need good contact or it's not going to work. And then I'm going to make sure my board's clean by making sure none of them are touching. Okay. Alright, and then our last resistor number 5, is R5. It's our 16 and 16K ohm resistor. Should be brown, blue, orange, gold. Brown, blue, orange, gold. Is that brown? Man, that's hard to see. I believe that's brown, blue, orange, gold. I don't think I have the right one. Let me pull out brown, blue, orange, gold. I believe that one right there is it. Brown, blue, orange, gold. Let's look at this. Sometimes those colors are hard to look. Brown, blue, orange, gold. Brown, blue. Yeah, I believe that one's got gray in it. Okay, brown, blue, orange, gold. This is my 5th one. It's going to go in 1C and 9C. 1C and 9C. So I'm going to have to hold this back here. 1C and 9C. Ooh. Well, y'all, 1C and 9C. There we go. 1C and 9C, so you can see it. 1C and 9C. Alright, make sure they're not touching. These two right here are definitely close. Okay. Alright. Okay, the next thing we're going to do is, these are all resistors. We have 5 resistors. We put them in accordingly. Alright, so the next thing we need to do is we're going to add a wire. So grab you one of your blue wires. If you already have some that are stripped, go ahead and grab them. So I've got my blue wire. And we're going to insert our wire into 1D and 1I. 1D. So 1D up here. And then 1D and 1I. So we're looking for I, which is all the way over here. So let me see if I can hold this. And 1I. Remember, we don't want anything touching anything, so, but we want to make sure it's got a good circuit or good connection. So I may need to see how I was working that. Just kind of pulling that over a little bit so it wasn't touching. I could bend this up. I just don't need it to touch. Good and clean. Okay. All right, and then the next thing we're going to do is we're going to attach our LED. Now remember, LEDs have polarity. How do we know what the polarity is? Let's take a look at this one. See if I can get it in here. What is polarity? I hope you said that one of them is positive and one of them is negative. Now I'm asking you which one is the positive side, which is also known as the anode. The anode is positive and the cathode is negative. So which one is which? Well, if we know the anode is positive and we know the longer one is positive, we're going to insert the longer one in first. Okay, so that's going to go into 19I. So my anode will go into 19I. So here's my 19. Then I have to see my I is the second one in, so 19I. And then my cathode is going to go into 20I. So 20I, so all in the same row. So I'm just going to push it down. 19I and 20I. Alright, and then let's add our wire 1. So our wire 1 is going to go into 1A and 11B. 1A and 11B. 1A and 11B. So 1A. It's hard to look through my phone and then try to do it. 1A. So it's going in 1A and 11B. So I need to find 11 on my thing, on my circuit board, and then put it into B. 11B. Yes, there we go. Alright, so 1A and 11B. 1A and 11B. I'm going to make sure nothing's touching, so I'll zoom in. Looks clean. Alright. And then we're going to go ahead and add our wire 3, 19J. So I need one more. And we're going to put this into 19J, which is right beside our LED. So we got that. This one's okay. And then our last thing that we need to do is do our battery snap. And remember, it has a positive and negative, so it has polarity. 11A is the positive. Do you remember on a battery snap which one's positive? Yes, the red one. Red is positive, and our black is negative. So 11A is our positive. 11A. 11A. So it's going to be right beside the wire. I'm going to try to hold this, but actually I guess I'll just do it and then I'll show you. Sorry, it's just really hard to... Okay, so we had our battery snap at 11A, and then our positive, and then our negative is going to be at 20F. 20F. So let's look down here and then I'll do it 20 and then F. So it's going to be all the way over on this other side, but we're still going to be in 20. So it's going to get right here. Right there. So 20F. And you want to make sure it gets a good connection. Okay. Do not put your battery in yet. Alright, let's make sure, go back and make sure everything's clean. Make sure nothing's not touching. This wire's not touching. Do you notice that that wire is up in the air? Battery snap is here. We've got it connected. We've got our wire 1 and our wire 2, and then we have our wire 3. We have resistors. Do you see anything touching? Because I don't. Actually, I do. I see this resistor touching that resistor, so we do not need that. Alright, so does everything look clean? Do you have everything clean? If you don't, pause the video right now and get everything clean, meaning nothing touching nothing. No metals touching metals, no resistors touching resistors. Everything looks good, it's neat, it's organized at where it should be, okay? And then when you get everything cleaned, then pause the video. Alright, I want to tell you at this time that J19, this wire, the wire that we never connected to another place, is going to act as a probe for us. So we're going to use it to show the different resistor wires have on the LED. So in just a moment, I'm going to ask you to put your battery onto it, and then I want you to take this after we do it and touch it to the first resistor and watch the LED light, and then to the next one and watch the LED, and then to the next one. Okay, but at this time just leave your probe in the air, just like we've had it. All right, just like this. And I want you to add your battery. So, nope, I got the first time. So I'm going to add my battery. Did anything happen to the light? It didn't, but yet I have my battery connected. So why is that? All right, so if we look on page 19 in our book, there's a schematics map of what we have done. Resistor 1, 2, 3, 4, and 5. We have our 9-volt battery. We have current flow. We have our cathode with our LED light. We have our anoid, and we made sure we put them in the right place. But look what happens when we have this wire sticking up and it's not connected anywhere. See, there's the lead wire right there, and it's not connected. It's the same thing as on our schematics map. There is no way for the current to be back. It's not connected. So that's why the light never powered on. All right, so now go ahead and leave your battery pack on and take this probe and touch it to your first resistor. And when I do that, I want you to watch the light. So I'm going to take this and touch it to the first one. Let's see what happens. In my phone, it looks like I'm touching it. Oh, did it work? Sure it did. Okay, let's touch the next resistor. And the next resistor. Can you see the light? Okay, let's try the next resistor. And the last resistor. Sorry, my finger's in the way. Okay. Make sure to only do one at a time. Okay, so what's your comparisons? If you were writing down resistor 1, 2, 3, 4, and 5, which one is the brightest? Which one is the dimmest? Oops, sorry, I don't realize I have to look away from my phone, otherwise it looks like it's closer up. Sorry about that, y'all. Okay, so here's our first resistor, second resistor, third resistor, fourth resistor, fifth resistor. Okay, so I want you to look at this, think about it, pull out your sheet where you calculated the different resistors, take a look at it. Which resistor had the greatest amount of current flowing through it? So if we're looking at it from this angle, we're going to say this one's our first one. 1, resistor 2, resistor 3, resistor 4, and resistor 5. So which one? The 220 ohm, the 1K ohm, this is 220, this is 1K, 3.3K ohm, the 6.8K ohm, or the 16K ohm? Which one had the greatest, brightest light? I want you to play around with it and keep looking at it. Look at the light when you do it. So if you said that 220 had the brightest, it sure did. It sure does have it, the brightest light. So that tells me that as I go this way, this resistor is providing more resistance. And this one even more because it dims the light. And this one even more resistance. And this one even more. If I can get it to stay. Compare this one and then compare this one. Okay. So, it's good to try different resistors. You could leave this set up. You could switch out different resistors and put them in there and see which one is brighter and which one is dimmer. And then just kind of get an idea and a feel for the different resistors. Okay, let's see. Please be sure and read all the information on pages 18 and 19 in your book. I did go over the schematics chart with you. I also wanted to say a byproduct of a resistor is heat. So do leave it on for a minute. Put it on one and leave it on there. Just leave it on for a good little bit. I don't know, maybe count to 60 or something. Maybe have to be longer than that. Probably should get my finger off of it. And see if it builds heat. This one is the brightest light, so maybe we should do one of these smaller ones and see if it builds heat. It's providing a lot of resistance, so the light's dimmer. So a byproduct of a resistor is heat. And if you leave the probe on a resistor a long time, it will begin to get hot, or it can begin to get hot, okay? And long defined. So let's see how, I don't know that was, maybe a dash warm. So try that. Maybe count to 60. I don't think I quite weighted it to 60. But I do feel it compared to the resistor beside of it. And then I touch that one. There's a little bit of heat. Not much, but a little bit. Certainly, if I just touched it, I probably wouldn't even pay much attention to it, but because I know what I'm looking for. So you can leave it on there a little bit longer. Okay, so if you're using this in the real world, or if you're trying to invent something, they can use resistors, the heat off of resistors, to make heated seats or electric blankets. Those are two examples. So some cars have heated seats in them, so it'll give you an idea that resistors are in there. All right, pretty neat. Pretty neat. Sometimes in things that heat is not needed, they'll take and use fans to offset the heat. So if you have a lot of resistors and they're resisting, I'm going to fill that again. Yeah, you can tell. If you compare it to the one beside of it, you can semi-tell that it is a little bit warmer. Certainly not hot to touch. But if you had a lot of resistors in your project and you needed to offset the heat that was in them, a lot of times they'll use fans, and the fans will help keep the resistors cool while they're needing to work. Pretty neat little lab. I hope you enjoyed this. This is lesson 5. I hope you enjoyed building the circuit today and watching how different sizes of resistors, allow more current to flow or less current to flow. And that's the job of a resistor. It resists, or it creates resistance to current flow. All right, happy learning. If you haven't subscribed, hit the subscribe button, and you should be notified if you'll click the little bell. That'll help you.